this morning. We normally have about 4 times this. I guess it's just busy.
I'm sure it is busy. It's getting to be that time of year. Well, with that said, I'll go ahead and get started. This presentation we do a lot for architects. We have a lot of people and resources in the field. As was mentioned, my name is Evan O'Connell. I represent KEENE Building Products in Texas, Oklahoma, and 13 other states in the South and West. I head up our business development for that segment of our business. In the field, we have currently 13 people in Texas and 1 in Oklahoma. I'm in Oklahoma. I am based out of Norman. But as I said, we've got probably 30 people total in our company that represent KEENE. KEENE Building Products, just really quickly, has solutions for the wall, has so drywall Rainscreen will be heavily featured in this presentation, but also some mortar collection stuff. We do a lot of noise control solutions for multifamily, so we're very heavy into that. And what I've been spending a lot of time recently on myself has been the waterproofing for balconies and a little bit below grade on multifamily stuff, as well as some roofing ventilation solutions. And there's a whole host of companies that they have under the umbrella that do a variety of things, typically with the exterior with flooring. This presentation, healthy walls equals rain screens and ventilation. These are some of my AIA slides here. So we'll skip through these. Okay, so this presentation really has 3 objectives for learning. First would be to analyze the way that various wall systems are being detailed, identify potential flaws that can lead to moisture problems, and then establish the best practices for designing and constructing a well-ventilated and drained wall system. So we look at some of the most common problems associated with exterior walls. We find the same things over and over, and those are leaks. Those leaks then cause the potential for mold, mildew, and deterioration of the structure. This can also cause a reduction in indoor air quality. Big problem for people like me that have pretty severe allergies. Those moisture problems can also lead to energy efficiency problems and the loss of energy efficiency. Of course, moisture intrusion is going to increase the cost of ownership due to repairs and lower energy values. And then, of course, things get really bad and we get into court and litigation costs. So since we know what the common problems are, it'd be nice to know what those causes are. And we see, really the same few things over and over and over again. And that is inadequate detailing of terminations and transitions between different systems. So the roof to the wall to the foundation. The sequencing of construction is obviously a big obstacle, and the bigger the project, the more the sequencing becomes an issue. There's the coordination of multiple trades. So when you talk about the building envelope in particular, you're going to have a WRB installer that's going to vary across regions in the country. You're going to have a window installer a lot of times, maybe the same guy, maybe a different person. You're going to have door installers, almost always a different trade. You're going to have your cladding installers. Again, you may have multiple trades doing that. And then you're going to have a bunch of people poking holes into your building envelope, right? So you're going to have your mechanical trades, your plumbing, your HVAC, your electrical. So all those people touch the building envelope and makes it a difficult thing to control. The other thing we see is insufficient supervision to manage the process. It's hard to be an expert on all those things and hard to supervise all those different trades. Probably you're talking 7 to 10 different trades touching that envelope. And then, of course, insufficient quality control processes. So not just managing it, but then who's watching the people doing the work. So it's very, very tricky. And this is why we see in high-end residential and of course in multifamily and commercial jobs, we're seeing the rise of building consultants, envelope consultants. So what are the solutions? Well, we've got to control air and water leakage through system design and system performance testing. When you look at product compatibility, again, a lot of trades are bringing their own products to the job site. So how do those things work together? Can you design a system approach? Obviously, work sequencing becomes really important. Some things have to be or work better when they're installed before other things. And then obviously educating owners, builders, and the trades about the importance of the work. So this presentation will focus, at least initially, a lot on stucco type veneers, thin stone veneers, and the like. So the inherent problem with stucco on wood frame, well, very simply, wood expands and contracts at different rates than stucco. Stucco is hard, it's pretty stable. Wood is, especially now, it seems like wetter than ever, and then it's going to dry and shrink. When they warm up, cool down, those things are going to move at different rates. So there's the old saying, I'm sure you're all familiar with, stucco that's cracked and stucco that's going to crack. So we need to build in details that can help minimize this cracking. What those things look like, pretty simply, proper thickness and aggregate gradation. You said you recently had a stucco presentation. You know, I always tell people, you know, go with premix. There's less variance there. Expansion and control joints, they need to be placed at regular intervals. It's 144 square feet, needs one. You know, we see this get overlooked a lot. Casing beads, very important to the system. And things that we see done incorrectly or omitted entirely a lot, weep screeds and other drip edges. For some reason, they're looked at as being unsightly, but they're vitally important to the performance of the wall system. Not only they're installed, but they're installed properly. So what some of those accessories look like, we've got our weep screed here on the top left, our casing bead, and our control joints down at the bottom.
Yeah, unfortunately, those details, we're okay with weep screed throughout most of Texas, or a lot of Texas. There's some areas of Texas, they literally don't even have it at the supply house because nobody uses it or enforces it. Control joints, we see that quite a bit, especially in the Metroplex and the bigger cities, but very rarely do we get that casing bead detail correct.
Mm-hmm. Yeah, it's tough. And the other one, since we're kind of talking about flashings here, this presentation does focus on heavily on stucco, rain screens, but also cavity airspace. Probably the #1 mistake that I see in the field is actually has to do with brick and masonry through wall flashing. There's currently little or, well, no code enforcement that I know of having proper through wall flashing details on brick veneers. And in my market, I'm in Norman, it's very common to see high-end homes built with brick and then having stucco applied over the top. But you know, those walls are still very permeable. Water goes to the backside of that brick, and finding an exit for that is vitally important to the long-term performance and durability of that building.
Oh, well, yeah. It's my understanding, I think the city of Stillwater, I know the city of Lubbock did, they amended out weep hole requirements and masonry, just amended it out of the code.
Yeah, you see all kinds of interesting things. I don't know about Stillwater. I have to check on that. You know, we're going through right now the amendments submittal process in Oklahoma for the next code. So I think we're looking at 2018, and actually this is well timed for that. But anyways, so I don't know if they can amend things out. You can certainly add things in Oklahoma. But I don't think you can go below the minimum here. All right, so some other defects we see, not enough fasteners securing metal lath, or too many fasteners can also be a problem. Undersized fasteners that don't penetrate deep enough into the framing. We see this probably a lot. Again, it's not something that ever gets checked for usually. Improper lapping of WRBs, and the required gaps between wood-based sheeting panels. These are all contributing factors to the problems we see. So what does a rain screen wall look like? Well, with stucco, we have this drawing. All these drawings are available on the KEENE building website for download. But anyways, system consists typically of, in stucco, the code requires a 60-minute paper or equivalent and a rain screen, or depending on where you are, at least two layers of grade D paper is what's required. So the rain screen is admitted into the code as an exception to the 2-layer requirement. Adhered masonry veneer cutaways look very similar to the stucco wall, right? So you're going to have your sheathing usually. You're going to have your WRB. You're going to have a rain screen and then your lath applied over that. Of course, at the bottom, you want to have proper detailing, so casing bead, optional, and of course our weep screeds. Is something we're seeing more and more too, as I say, usually sheathing, but the sheathing requirements are not all that stringent, and I'm already starting to see a lot of builders trying to minimize their use of exterior sheathing. This is very common in the Southwest, which we cover, and with the prices becoming more and more common in our markets. If you haven't seen it, their builders are definitely talking to me about it. So as much as 90% of all water intrusion problems occur within 1% of the total building exterior surface. It's not the actual manufactured waterproofing systems or the envelope systems that leak usually, but the construction, the details, the installation of terminations and transitions is where we see the problem. So that's a quote from Michael Cabal. Another quote from Joe Seabrook. You guys are probably familiar with him. More insulation and tighter buildings means the exterior is now colder and wetter than previous. So no heat escapes from the inside and no airflow through the wall to help dry the exterior. Claddings hold moisture longer. You couple that with less forgiving building materials like OSB, and you have problems. So it's important to look at some of the changes we've seen over the last 30 or so years and the rise of OSB versus plywood to understand where some of these problems come from and what the differences in the materials are. OSB hit the market in the late 70s and really has become the dominant sheathing material. We're starting to see now, of course, the rise of thin profiles, but still a lot of OSB out there. Plywood, if you look at it, is a very permeable product. So 10 perms is going to be defined as very permeable by the IRC and the IBC. OSB has a higher density and a lower permeability. It's now got greater than 75% market share nationwide. So there's more resin OSB, which lowers the permeability. So about 2 perms. Of course, you compare that to plywood, which has 10. What this means is that OSB takes longer to dry out, giving trapped moisture more time to degrade the building materials. Of course, there are pros and cons of everything. So OSB has pros. It's a versatile building material. It's very consistent. It's a manufactured process, has good shear strength, and it's generally been more affordable. OSB, there's some cons, of course. It is heavy. It has a much lower moisture tolerance. And some people look at the value a little differently. Plywood, it's always had a good reputation. It's stiff, it's strong, it's durable. It has good resistance to moisture, and it dries very quickly. But the biggest con, and it's becoming more and more of a challenge with all building materials, is the cost. Of course, the other big thing that goes into our building materials, quite literally, is going to be our fasteners. And if we look at the most common one, when we're looking at adhered masonry or stucco veneers, we're usually talking about staples. So with staples, I'm starting to look at those as more antique technology. Staples can be applied by the hundreds or even the thousands by one guy. You could have an excess of 6,000 holes created by staples on a 2,500 square foot structure. And a single fastener can be a source of failure. So we're starting to see in many WRB systems anyways, the addition of cap staples or cap nails. And these are also becoming more common with to attach lath and other types of cladding with as well, including rain screens. And these will provide increased performance. Basically, you can get 20 times the holding power with a cap fastener than you can with a slap staple. And many regions are moving to change the code or adopt it to eliminate staples entirely. All right, so now we'll talk about the 3 most common types of wall construction we see in North America. Those are load-bearing masonry walls, barrier wall systems, and Rainscreen or cavity wall construction type systems. So the first one is our load-bearing masonry. This is where the concrete masonry unit is grouted solid. It's becoming less and less typical because it is very expensive. But the way it works functionally is that it protects against moisture just by the sheer mass of the wall. So sometimes we refer to them as mass walls. We typically don't build with this type of system anymore, and especially residentially, because primarily the cost is quite a bit higher, and it's also very, very hard to insulate. So as the energy codes change, the requirements on insulation is getting greater, and it's harder to achieve that with this type of construction. Next, we see what's been common is the barrier wall system. So, and this system is one of the more common uses that we see in North America. And the theory is that you should stop water with one single layer plane. The problems, of course, are that there's no control for water penetration. So usually this type of wall system is constructed with one layer of paper or house wrap, typically maybe a sacrificial layer when installing some sort of exterior cladding. And then you're relying very heavily on caulks and sealants to be used for those permanent joint sealant. Really, when you think about how these are constructed, they're constructed as imperfect barriers. So there are many factors that come into play when constructing a barrier wall system, such as using the specified materials correctly, getting the detailing correct, and having good workmanship. In many parts of the country, the KEENE products are distributed alongside of Tyvek. And what I can tell you about those products is that they have a whole team of people in the field constantly training and retraining people on how to install it. There's a lot of reasons for that. Most of them are turnover or lack of oversight. But these products, if they're not being very well the oversight's not very, very good, they're going to be installed incorrectly. And some of the common things that we see with WRB installation is bad roof wall intersections, reverse shingling all over the walls, whether it's with a wrap or a tape sheething joint type system, incomplete coverage of the building, detailing with penetrations is a big one we see omitted. Poor window and door flashing details, either just flashed incorrectly or reverse flashed, or not flashed at all, not using code compliant materials. Improper head flashings is a big thing we see in the field. And then, so, if you think about all those things that can go wrong, it's a little scary to think about what can be missed. And that's with the barrier wall system. Now, the third type of wall construction we see is a Rainscreen system or cavity wall construction. And in this type of wall system, we're not trying to stop water from getting behind the cladding. We're assuming that water is going to get past the cladding. And so the penetration of water that gets through is collected for discharge through flashing materials, through wall flashing in brick, or through weep screeds with stucco and thin stone veneers. Ideally, you'd like to see at least 1/4 inch of airspace, not only for drainage, but also to promote drying. So what we see is that with less than 1/4 inch of airspace, you don't see a lot of drying. You can certainly achieve drainage, but you don't provide enough space to create convective drying that we're looking for. So cladding really should be looked at as being like primarily cosmetic. I mean, sure, it has some function. It does stop some water in some of these bigger wall systems, more massive wall systems like stucco and brick. but it really should be looked at as a design element to accent the structure and not be intended as the primary means to hold out air or water in the structure. So if we're not going to hold out air and water there, we need to talk about creating a space. And to create a space, we call it Rainscreen, but really a ventilated space is what we're talking about. It can be achieved with a product or just a gap between the primary cladding material. So there's three primary things that go into that. One is a water resistive barrier. You need to have that in a Rainscreen type system. Then you need to have an airspace. That could be, as I said, it could be a 1 or 2 inch space in a brick cavity. It could be a Rainscreen, like a rolled type product. It could be furring strips. And then you need to have the exterior veneer applied outside of the airspace or over the top of the airspace. There are many, many benefits to a Rainscreen. In basic terms, we're creating a ventilation space and a drainage space or cavity to allow water to exit the wall system at various points. A Rainscreen product creates airflow and it allows moisture inside of the wall to dry more quickly. Drying can occur from the outside in or the inside out. A Rainscreen product also prevents mortar from coming through the lath and attaching to the building paper, creating what we call mortar damming. We do have some pictures of this later in the presentation that I will be showing. And then one of the biggest benefits of a Rainscreen product is that it can be applied through transition materials with dissimilar veneers. So these transitions have a high probability of water entry and are pretty good. Pretty often we see failures in this area. So they could be, for instance, like a wainscot's a good way to think about that, where you may have a brick or a thin stone veneer on the bottom, and then on the top you may transition to like a stucco or a siding type veneer, wood or fiber cement, those kinds of things. So really common design elements, and Rainscreens can help in those areas as well. So what's happened to the walls over the last couple of years that's created more problems? Well, one of the big things is we've added more and more insulation to the walls. And so this has changed the way in which, and the capacity for walls to dry out. We've also changed the building materials. So as I mentioned, we went from plywood or faster drying materials to OSB. At the same time, we've changed the air tightness requirements for our building. So everyone's focused on lowering our air changes per hour. Air changes is a big source of drying capacity in a structure. So the less air changes you have on the inside, the less heat flow you're going to have through the building, the more drying capacity is needed on the exterior wall assembly. Obviously, our occupant comfort expectations have changed. And what this has resulted in is lower tolerance for wetting in the wall and less drying capacity of the exterior cladding. So here's some of the problems that we've seen. I've got some pictures. In the past, buildings were traditionally designed to deal with air movement. The systems allowed convective and stack effects in buildings. So you'd have wind washing through the cavities that would dry the walls from the inside out. You'd also have leakage from the outside in, which would create an equilibrium state of moisture within the wall system more quickly. So here's another picture, kind of a close-up. You can see what this looks like from the outside of the building. So in order to design and build safe, healthy, durable, comfortable, economical buildings, we have to control airflow. Airflow is a huge transporter of moisture, and it will impact the materials used in the building's long-term performance and the structural integrity. So when hot, humid air is pulled through cracks and gaps in our high-performance buildings, it will hit cooler interior surfaces and has the potential to condense into liquid water. This condensation then can produce even more problems. It soaks in the building materials, and it becomes a prime source for mold and rot. So here we can see a facade being torn off. So from the roof to the foundation, everything in between the elements are always trying to force their way into the structure. And the largest part of most of these structures are the walls. Designing a high-performance wall system not only is critical to protecting the investment in the house, but also allows the building to perform at optimum levels. And a Rainscreen wall system is the ideal way to provide an attractive, long-lasting, high-performance wall system. There are other problems that can occur as well. This picture here is a thin stone veneer. And when I think of thin stone veneers, they're really direct applied, masonry type veneers are all very similar. They have a lot of advantages, both with regard to cost of the building, but also they're very aesthetic looking as well. Thin stone veneer, though, is typically much more porous than natural stone or cast stone, which can result in water absorption. The picture we're seeing here is actually rot from the bottom of the structure up, and this is caused through capillary action, which is a big mechanism for movement in these types of materials. These claddings should be considered reservoir cladding systems, which means like all masonry materials that can store water. Other problems we see is are with the building material choices, particularly with the weather resistant barriers. What's required by the code is just black paper is what's required. It's the code basis. And there's a lot of problems that we see with that particular building material. It has a very low resistance to tearing. It shows black paper is shown to be highly vulnerable to deterioration after periodic and or long-term exposure to water, unless there's an air gap, that'll slow it down a little bit. And another problem with building papers and WRBs in general is that they're very hard to repair after construction has been completed. So really you only get one shot at doing it, so it's important to do it correctly. Rainscreens will minimize a lot of these factors. So WRBs are really important. It's important that we define these though for this presentation. So the primary purpose of a WRB is to prevent water intrusion. A lot of times we also see them specified as air barriers as well. The primary WRB needs to be durable enough to withstand the job site challenges. So obviously it has to make it through construction, and it has to manage water that may enter the wall system after it's installed. Another key thing is to look at is not just the construction phase, but the durability of the products. Really, as I mentioned a couple slides ago, your WRB and your Rainscreen system has to make it through construction and then has to last for the life cycle of whatever cladding material you've chosen. And preventing or minimizing air and water intrusion is vitally important to help maintain a healthy environment for the building occupants. All right, just to recap though, black paper, very problematic, has a low resistance to tearing, can absorb water, retain moisture, can be reduced a little bit with the implementation of an airspace. It's an organic material, so it can act as a food source, and it's hard to repair post-construction. Some other systems that we see very commonly now, panelized WRB systems, which have their own set of problems. You have many untreated fasteners, both those used to construct the building, but those used for cladding fasteners as well. These are very low perm products. Again, OSB is a very low perm product, and the resources and details to install all these products can be difficult to locate. So the solution to our problems really comes through a good understanding of building science. And what we need to know is that heat always moves from higher concentrations to lower concentrations, and moisture moves in very much the same way. It moves from higher concentrations to lower concentrations, and the pressure that's generated inside or outside their building is always going to be looking for equilibrium as well. So we have wind pressures from the outside, mechanical pressures most of the time from the inside. And it's going to be a driving force for air and for water. It's important to really think about materials are going to get wet. So we have to have a plan on how we're going to get those materials to dry out. So we can think about this using what we like to call the 4Ds, and those are deflection, drainage, drying, and durability. And deflection, pretty straightforward. We want to reduce the amount of water that gets onto the building. This is primarily accomplished in residential construction with overhangs. Then we want to have proper drainage. So we know that our cladding is going to get wet. We know water is going to intrude through the cladding. So we need a path for that water to go. Then third, and this is important, is since we know the building is going to get wet and we're going to drain that water out, then the next thing we need to think about is how are we going to dry the cladding? As mentioned before, we're getting much less drying capacity from inside the building because we've controlled that through the use of increased insulation. Spray foams are very good interior air barriers, don't allow much movement from inside to out. So the solution there is creating airflow on the outside of the building behind the cladding so the cladding can dry in both directions. And then finally, durability. So the materials have to have adequate tolerance for moistures and need to have a life cycle appropriate for their intended use. So here we'll look at some of the codes. This is kind of an older one, but this does talk about weep screeds and the need for those. Talks about the size, 3.5 inches, and it shall be provided at or below the foundation plate line or the exterior walls, stud walls in accordance with ASTM-C 926. So basically right below that, you can see weep screeds shall be placed a minimum of 4 inches above the earth or 2 inches above paved surface areas, and shall be a type that will allow trap water to drain to the exterior of the building. Vitally important. Often we see this done incorrectly, and it's almost always because of cosmetic reasons.
Yeah, it's very rarely we see that done right. We went through this ASTM standards in that webinar, and I'm telling you, you just hardly ever see it done correctly.
Yeah. Yeah. If we look at Rainscreens and some of the coming codes in the 2018 IBC, so this is already being adopted in some areas. Weather resistant barriers. Typically, again, IBC is going to be talking not about wood-based structures, but about gypsum sheathing a lot of times. But they're required in the IBC 2 layers independently installed and independently shingled. In 2018, where the water-resistant barrier is applied over wood-based sheathing in climate zones 1, 2, and 3A, a ventilated airspace shall be provided between stucco and the WRB. So really interesting code change there. The 2018 IRC made tons of changes. Obviously these will be adopted, differently in different municipalities, but here's kind of some of the things we're looking at. So WRB is applied, in section 703.2 is where they talk about WRBs in the code. But where you're doing stucco, this is what we're talking about here, 703.7. So in particular, they're saying you have to have a WRB equivalent to at least 2 layers of grade D paper. The layers shall be independently installed, and so that each layer provides a separate continuous drainage plane, and any flashing installed in accordance with 703.4, again, right after the primary WRB part of the code. And they're intended to drain the water from the stucco kind of in between those layers. So basically you have an intervening layer, if you will. They added, it was already in there in the code, but they made it a little more clear in this revision, where you have a WRB that's applied over wood and has a water resistance equal to or greater than 60-minute grade D paper, then and is separated by stucco by an intervening substantially non-water absorbing layer or designated drainage space. So designated drainage space would be very simply a rain screen. Substantially non-water absorbing layer is a little bit ambiguous, but typically I think about that as being foam. And 60-minute grade D paper equivalent They unfortunately don't define that very well in this part of the code, but they do in the 2021 version, which
And as far as Tyvek versus that perforated builder wrap that they're using, I'm assuming you're about to get to that. But wait, I had a question come in. So house wraps are equivalent to the 2 layers, and not all house wraps are created equal. Didn't know if you were going to expand on that.
yeah, actually I will. So in 2021, they do a much better job of saying what is a type 2 air barrier or a 60-minute paper. So again, we're looking at specifically, I'm looking at the Stucco part of the code. So the primary WRBs are listed in the earlier parts, 703.3-ish. So this is a little further down. But the at least in the 2015 code, the only requirement for like a grade D building paper is a weight. It's a weight specification is all that's referenced. So what they're moving towards is more and more performance-based, code compliance or calling out more and more tests. And you can see that even from 2018 to 2021. So what's kind of interesting here is if you look at number 2 under the dry climates, the WRB shall be a 60-minute grade D paper or have a water resistance equal to or greater than 1 layer of WRB complying with ASTM E2556 type 2. Type 2 is a direct comparison, or a pretty direct comparison to a 60-minute paper. So that 2556 test has a type 1, excuse me, a type 1 and a type 2. That type 1 is typically going to refer to your like more like 15-pound type equivalent papers. Type 2 is going to be more of like your 30-pound type papers. So that specific test standard calls out much more specific criteria for air and water holdout, and then equates other building wraps. So that's where you're going to find compliance with your plastic, type products like Tyvek or like a perforated wrap type system. They're going to reference that 2556 test. Then this goes on to talk about non-water absorbing stuff. So the water resistant barrier shall be separated from the stucco by a layer of foam, plastic, insulated sheathing, or other non-water absorbing layer, or a designated drainage space. So they made it a little more clear, what is non-water absorbing, and they started to call out, okay, foam plastic's not substantially water absorbing. They still leave some ambiguity there, so that the intent isn't to eliminate products, right? It's supposed to be inclusive. So if you can say what non-water absorbing is, then you could use it, or a designated drainage space. And what's really interesting here in the 2021 IRC is that they then start to talk about marine climates, and moist climates. So right underneath that, they added a whole new section. And actually here they split it into dry and moist or marine. So this is going to be relevant to us. So in moist or marine climate zones, and they give you the chart for that, the WRB shall comply with one of the following. In addition to complying with 703.7, that's above, a space or drainage material not less than 3/16 of an inch, 5 millimeters in depth, shall be added to the exterior side of the WRB. In addition to complying with 703.7, a drainage on the exterior of the WRB shall have a drainage efficiency of not less than 90%, as measured in accordance with ASTM E2273. So that's another standard test method. It's been around for a long time and very widely used in the in EFIS type construction. So big changes coming, and they're going to continue to come. I've been telling everyone for a while now that if you haven't learned how to install Rainscreens, you should, because it's not, if, it's when you're going to adopt them in your construction in our climate zone. Kind of interesting, this is the most stringent code in North America that requires a Rainscreen, requires a 10 millimeter gap, and that's in Canada. So it's pretty pretty universally known that if you create around 1/4 inch, that would be closer to 6 millimeters. But you know, they said 3/8 of an inch in the 2018 or the 2021 code. Water droplets will form and they will drop. Also, when you create larger spaces, you create more potential for ventilation, which is going to be key in drying out these wall systems. But so we sell a lot of Rainscreen. I can tell you that our most popular product for a long time has been that 1/4 inch, which is right at 6 millimeters. But this year, the cost difference to go from 6 millimeters to 10 millimeters is very, very small. And we were doing like 5-to-1 last year of 1/4 inch to 10 mil. This year, it's about 2-to-1, 1/4 inch to 10 mil. So we're starting to see, you know, people not only pick it up, but, you know, adopt best practice.
Had a question or a clarification come in. So self-furring lath provides for the space requirement?
If it's, I mean, I'm not sure if it does.
Depending on the code edition and
Yeah,
or-
probably not, because lath is, I mean, because it's you know, the concrete or excuse me, is applied directly to it. So typically, it's not going to give you the space. The space is going to have to be behind that layer.
behind that, yeah.
Yeah. So I probably jumped ahead of myself here, but it's something we talk about a lot: drainage and drying. 1/4 inch is really where you want to be at when it comes to drainage, creating drainage, and also creating ventilation. So you're going to get that capillary break. It's very well established, and right around that that 3/8 mark. 1/4 inch is just a little bit greater than that. So when we talk about, you know, drainage mats in particular, we should kind of understand what are the best characteristics to look for in a roll. So typically, roll is one of those things. So there are, you know, sheet applied materials. Roll goods are typically going to be applied more quickly. A lot of these products will have what we call a selvage edge, which will cover your horizontal seams. It'll also allow you to roll that back up at the base of the wall and create a bug screen. I'd like to find a product that wraps well around corners. So the installers love to have their really tight corners, and they tend to cut materials that don't do that well. It's kind of a picture of what this installation looks like. So you can see, I think we've got a good understanding, but you have your primary weather barrier, then your Rainscreen product, then your lath goes over the top of that. Rainscreen here pictured at a window jamb. It's important to note that flashing details do not change when you're incorporating a Rainscreen product. The Rainscreen is not a weather resistive barrier. So again, if we look back at the codes, it's listed as an exception to the 2-layer requirement. So it's in lieu of. It is certainly not a water resistant barrier. Water is intended to penetrate it and drain down the primary WRB. Again, a little bit close-up picture of what this looks like. The layers installed: building paper, then Rainscreen, then your wire lath, then your scratch coat, then your manufactured stone. Here I've got some project pictures to show. This is, you know, obviously multifamily project. We're doing a ton of work in this space. They're usually really quick to adopt these things because it is much cheaper to build correctly and with some room for error the first time than it is to fix things later on. So again, when the building's complete, you can see, you know, there's no real differences visually from the street. The pictures I'm about to show you are from a reclad project. This was had to be done due to moisture intrusion and installation defects during construction. This resulted in a complete tear off of the sheathing all the way to the studs. The subcontractor submitted Rainscreen products to ensure, really in his mind, a belt and suspenders approach. And what he said was that it costs 75 to 80 cents a square foot, material and labor, to install a Rainscreen on a project versus $1,250 to $1,450 a square foot to reclad a building after the issues were uncovered. So the price, of course, of the reclad does not include the litigation costs that they went through.
Well, and the indoor air quality problems that become as a result of it, and the lack and the tenant unhappiness, and there's a whole lot more cost than that 12 to 1450.
Yeah, there's certainly lots of other costs that we didn't list there outside of the dollars and cents of it. So here's what this project looks like. Of interest, I told you I cover 15 states for this product. This project is in Phoenix, Arizona. So not a place that you think of as being real moist or getting a lot of rain, and yet they had tons and tons of failures. You can kind of see why some of that might have been because of the types of products they chose initially. But you can see that the new wall is going to be, the mock wall there, is going to be a lot more robust structure. So not anticipating a lot of issues there. The desert's really interesting because even though they don't get a lot of rain, when they do get rain, it all comes at once.
Right. Yeah. With that down in the valley in McAllen, Brownsville. Do you do much work down in Brownsville, McAllen? You down there very often?
I was in FAR 2 weeks ago.
Okay. I was in McAllen 10 days or so ago doing a field training, and that's that in that area of the state. Good luck finding a weep screed.
Yeah, it's tough. I'd love to talk to you more about that. Because I'm looking for people. Okay, so there are the main types of airspaces in brick cavity walls. Commercially, we see a lot of 2-inch airspaces. Residentially, 1-inch airspace is pretty common. One of the challenges that we're facing is with code changes is going to be keeping that airspace, because typically as they add insulation, I'm seeing people not account for that and not add space to the brick pocket.
In that house, just some of the roof details that the architects come up with, you're just begging for moisture intrusion.
Oh yeah, all the time. Especially, I mean, that one there with the chimney and the roof.
Good luck keeping that dry. That's just not going to stay dry.
Is there a cricket there? Who knows? I can't tell. This is what we see very commonly in masonry, brick walls, brick cavity walls. This is what we call mortar damming. It's important to note that your higher performance WRBs, and especially in our climate, are all vapor permeable, or they're supposed to be vapor permeable. When you have mortar, whether it's from brick like this or stucco, touching that WRB, it is going to dramatically change the performance of it. So it's important that you keep that mortar off of there. You can accomplish this with a Rainscreen, like a roll product. You can accomplish this with full mortar deflection products. We see those almost exclusively on government buildings, educations, although I did do on a co-op not too long ago. But that will prevent mortar from coming in contact, and it will also ensure that you have some airspace in that cavity wall. As I mentioned earlier, roll goods are not the only way to create an airspace. Certainly the brick cavities can have an airspace. You can certainly achieve a similar effect with furring strips. There are 2 types of furring strips that are common in the market: structural furring strips and non-structural furring strips. The applications for furring strips are varied. You can use them on interior walls, but they're also used pretty commonly on roofs, depending on the type of roof system you have and maybe the type of insulation that you're using on the roof, and then also in exterior walls to create what we like to call rain screens. Can be used with wood siding, fiber cement siding, and other types of cladding there. Here you see a black paper installation with a structural furring strip. So these are wood furring strips. This is actually a pretty clean installation. Here's a structural furring strip installation. You can usually residentially you need structural furring strips when you get much thicker foam insulation on the exterior of the building. So usually in greater than about 2 inches is going to require the addition of a structural furring strip. Some problems with wood, of course, here you can see this is going to be a problem, right? Rather than cutting those pieces of wood, he's just left the tops of those exposed, so they're going to collect water. That's going to deteriorate the furring strip as well as the building paper. And so a lot of issues with wood. It is structural, which is really the best reason to use it. But other than that, it gets wet, which can provide a food source for mold. It does have a high cost of installation, and it seems like that's growing every day. Of course, they can split, they can crack, they can warp, which can affect the finished look of the cladding. And wood furring strips can only be installed vertically, or they should really only be installed vertically on the wall. Otherwise, they will trap water. One of the solutions to this is an entangled net furring strip, which will get rid of a lot of the problems associated with wood. The synthetic or entangled net furring strips can be used with wood siding, metal siding, and other roofing and wall materials. They're very easy to install. They can be cut with a utility blade or with shears. They meet most building codes. Most importantly, they won't split, warp, crack, rot, or give you many of the other problems associated with wood. They provide no source of food for the promotion of mold, mildew, or bacteria. And what that looks like being installed from a practical standpoint is this. Of course, the cost savings go up dramatically the taller the building gets. One guy can carry hundreds of feet. 100 feet of a rolled entangled net furring strip will fit on your forearm. So, you can think 2 arms, you can carry 200 feet without trying very hard. A guy in a lift doing a tall project like this can literally take hundreds and hundreds of feet, and it's installed typically vertically from the top down. So you can kind of see in this next one what that looks like. So you can literally go up a lift, or you can go up a ladder. You can take 25 feet in a roll or 100 feet in a bundle. You tack it where you want it, and you let it fall, and you can work your way down the building. Typically, we'll also see these installed, if I go along the tops and the bottom of the building to act as a bug screen and increase ventilation. These types of products have been tested with many different types of cladding, so fiber cement as well as real wood products. And you can picture frame in your windows and doors too if you need to. And then they can also be used with not just with wood, but you can also use them with other types of exterior sheathing as well, such as exterior gypsum. Again, I prefer these larger fasteners, cap fasteners, provide superior holding power than staples, and typically become required for other types of building materials, other types of sheathings. Another system that we're starting to see a little more commonly is a Rainscreen, a UV resistant Rainscreen systems. These are necessary when you have open joint cladding systems because they do 2 things. They provide drainage and ventilation as well as long-term UV resistance. So almost all primary weather barriers that you see installed have a UV exposure limit. Most of them less than 9 months. Residentially, very common to be in that 4 to 6 month range. And then, of course, the Rainscreen can also provide a bug screen, and they provide an attractive black surface, so a dark reveal. So here you can see what one of those looks like being installed with a fiber cement panel system, and they literally just leave the joints open. Other things we're starting to see more commonly with like high-end building materials like Ipe or like synthetic decking we're seeing used on walls, which gives a really attractive look. Here you can see a pretty unique design involving an open cladding system. So usually, like I mentioned, you'll see this like in accents to the building. Again, this can also be achieved with real wood. So I did one about 2 years ago now in the Wheeler district in Oklahoma City with the open cladding at the pre-finished pine. It's a really, really cool looking project.
Super cool looking, but you better get that WRB right.
Yeah, you better get it right. Yeah, you better get it right. So this pretty much brings us to the end. I mean, the summary I like to give it here is ASTM tests are one tool that can help designers, but it's important to carefully evaluate how a system is going to be used and test it. We always encourage mock-up testing, mock-up walls for specific project conditions, and then understand fully how the building science is working here. So, you know, the 4Ds, the deflection, the drying, the durability of the materials that we're choosing, and of course the drainage. So I'll leave you with this quote: when we build, let us think that we build forever. Let it not be for present delight nor present use alone. Let it be such work as our descendants will thank us for.
Right.
I'm done. I can take any other questions that come in. My information's on the screen. You're welcome to reach out to me via email, text, or phone call, and I'll be happy to assist with any questions that I can.
Well, I haven't had any other ones come in. You've caught them as we've gone, but as we draw more and more light, and especially with the added details in the 2021 codes, and as more and more cities go to the 2021s, and as we, I had 130 or so folks on our Stucco webinar, and I can't tell you how many people came back and have said, oh my gosh, we are not even getting close to doing that right in my jurisdiction. And so I think KEENE building products and similar manufacturers that are making better products that will help ease the transition into doing it correctly. I hope to be generating some business for you, Evan, because I'm telling you, we're doing it wrong. We're building 30-year buildings in some jurisdictions in Texas, 50-year buildings in others, and 100-year buildings in just a few. It's just really become problematic. That's why I didn't realize you were out in Norman. The building official in Norman is one of our energy code ambassadors. He volunteers for SPEAR, my organization. So.
Oh, great.
I know somebody.
Yeah. One way that we tell people, or we try to get some of our builders that we work with to think about this is, you know, make a plan, make a 5-year plan. So like, what's something I could change to improve right now? You know, even if it's not being inspected, like what can I change today? Mm-hmm. You know, and then what can I change, you know, in the next year or two? What can I change in 3 years? And what can I change in 5? Yeah. So, you know, it's very hard. I know it's hard to be proactive and think about the codes that are coming, but as I said, and as you guys well know, it's not when you're going to be doing Rainscreen. It's not if you're going to be doing Rainscreens. It's when you're going to be doing it, right? Yeah. So the question is, you know, can I learn how to do it now? Are there projects I can start to use to learn on that? Right. I harped on the flashing. I mean, in Texas and in Oklahoma, there's brick everywhere. Yeah. I never see proper through-wall flashing. I mean, other than a few builders that I work with, I just don't see properly specified, properly detailed products. That's a very cheap and inexpensive thing, and it's a big source of liability because, quite frankly, there's no discharge from the wall, and it's in the code that it has to be done. So you're just doing it wrong. So let's start there, and then we can work on the things that are the way the code is moving.
Yeah. Oh no, that lintel flashing detail interface above windows is well, and it's all over the place. I mean, in some jurisdictions, we're just still working on head flashing and pan flashing for windows. So and then in other jurisdictions, hey, we're builders, they've been doing that right for a while, and now we need to. So it's really kind of all across the board, depending on what jurisdiction you're in. And I've done field trainings from El Paso, Texas to Beaumont, Texas. And it's the differences in construction practices from one to the other is pretty, it's can be shocking, really. And yeah, it's Robert chimed in. He's not so sure the volume builders think 1, 3, and 5. I think they're just, it seems like sometimes they're just trying to maximize profits. I hate to throw the builders under the bus. A lot of them are good and trying to get better, and You know, I use that similar approach. Hey guys, these things we need to be changed now, especially if it doesn't cost any more money, something simple like on framing, doing tees, you know, ladder framing tees, or doing your tees in such a way that you can get insulation behind it. It doesn't cost any more money, and it's in the code. It's been in the code for 20 years. Let's start doing that now. And some of these WRB requirements have been in the code. They've been in the code a while, or the manufacturer's installation instructions for some of that stuff. I mean, like when you showed that mortar right up against the Tyvek earlier, I can guarantee you the Tyvek manufacturer's installation instructions don't want your mortar touching their Tyvek. And so, you know, having some sort of means for, or if you're an inspector and you're out there doing a mortar tie inspection, if the mason is really slopping that mortar all back in there and removing your, basically reducing that wall's ability to dry, that those are some of the things that you need to start calling out on the red tags when you're doing these inspections. Well, Evan, if you're ever down in the San Antonio area doing any training or meeting with a builder or something, please don't hesitate to reach out to me. I'd love to meet you out on site. I know the development director with the city of San Antonio, and we're actually we're going to be doing some field training with his staff on some of these stucco installation details. Like I said, we're trying to make a difference. It's a slow process getting, you know how builders are. I mean, changing build construction practices can be like pulling teeth. So having another building science person and that knows the code and knows the building science on the job to not only back us up, but you know, if you've got a little wall mock-up with some of your products, that's a good time to, you know, showcase those as well. So be happy to work with you going forward. And again, apologies for the late start this morning, everyone. I don't know where my head was at, but we got it done, and we really right on time. We started about 10 minutes late, and it's 10 minutes after the hour. Thanks again so much, Evan. Any parting words before I shut it down?
No, I don't have anything. Just thanks for having me. Really appreciate the opportunity. And as I said, you know, don't anyone hesitate to reach out if there's anything I can help you with. And I have a large team of people available with similar knowledge and expertise, so I can put you in touch with them too.
Awesome. Fantastic. I'll be following up for sure. Thanks for joining us, everybody, and we'll talk to you soon. Bye, everybody.
Thank you.